It's kind of funny, there's a time lag between what I'm doing on video and what's actually on the screen, and so I have to wait for the other part to catch up. Anyway, so how do we implement big data? And the methodology they use is something called CRISP. Uh, and essentially, CRISP was started by IBM, and what it's about is coming up with a business understanding, understanding your data, preparing it, modeling it. When you evaluate it, you need to take a sanity check, and that's what you should do with everything. And then how am I going to go out and deploy it? And so what this chart does is pretty much tells you what goes on. For example, under data preparation, it's about selecting your data, cleaning it. Uh, there are different kinds of analytics you can use, and these are the most common algorithms. And so as you can see, a lot of these could apply to marketing. For example, similarity matching. Well, I know I have a profile, and so I have one kind of customer. Well, what if it turns out that there's somebody else who buys a different product who is actually very similar to the customer that I have? Those are people you want to go target. And so in terms of analytics, we're concerned about behaviors. We're concerned about what kind of products do people associate as being the same. Also brand, life cycles, buying likelihood, and product recommendations. What are products that people will recommend? And so what drives all of this are attributes, and those are the variables that help define it. And so I'm interested in knowing what those are, because that's going to drive what I should be focusing on. Like, for example, the most common attribute is age. Uh, A-B testing is, what if I have two different options? And so how do I want to figure out which one to use? Or is there a way that I can optimize it? And so what A-B testing is that you don't strictly look at percentages. And so if I wanted to figure out how to message uh, at a school, and so as it turns out, there's a lot more response to mobile than there is to email. And so the overall response rate comes out to be 8%. So one superior to the other. One little problem with that. Uh, and that's that teachers and students have biases. And so actually, if you combine it by just sending teachers email and students text messages, your overall response can go up to 11%. And so what that pretty much tells you is you can get almost 50% more performance by this mixing and matching. And that's what that does for you. Now in data systems, what is it you're trying to do? You're trying to learn. And so you need to find out what's going on. And one thing that's very common is you can get a lot of clicks, but not a lot of sales. And so this is why we have the funnel. And we have that funnel. So if I'm getting a lot of clicks, but I'm not getting a lot of sales, then I'm not doing something to push somebody over to that next step. It's almost like they've hit the chasm. So do I need to offer them discounts? Do I need influencers? Like, they don't know me, so they want to know me. Twitter. One thing Twitter has, some people think Twitter is just for celebrities. And that's that Twitter's got a lot of users, but not that many people really tweet. And in terms of the iWatch, what happened? iWatch 2 is doing a lot better, but iWatch 1 was in some circles kind of a bust. And so as you can see, the analytics we talked about, you can use to predict what's going to happen in these things. In terms of models, I won't go over this in detail, but here's are the different kind of data models that they look at and they're interested in. And that's objective functions, or what are the weights of attributes. And so that's kind of like regression in DOE. How do we balance things between lab testing and field prediction? Here's what an actual model evaluation is, and that's that based on that data, I want to create some kind of predictability. And that predictability comes through probability. And probability gives me expected values, and so I can figure out what my actual cost benefits are. The way data's progressed is it started out as big data, and it was more just about capability, and now it's more about interactions. And analytics was about statistics, and now it's about different kinds of data. One thing that you see in technology is that it tends to track Maslow, that at the very beginning you use it based on the simple functions it does, and then as it gets older and you progress, it starts to go into the higher level functions such as esteem and behavior, and that's what we see in data. First it was just about garnering statistics. Now we wanted to figure out how people think. In terms of applications of big data, uh, you can use it for your own personal use. And that's what Dr. Cho, he's used data all throughout his career. I've used it for product development, risk, R&D. Uh, some examples is I designed a simple algorithm to pick against a football pool because there were only 26 people. So the thing is, when you have 100 people, you're going to get outliers, and the outliers are somebody's going to do ridiculously well, but at 26, there aren't outliers. So all I needed to do was predict better than 50% every game, and I could win, and that's what happened with my algorithm. My algorithm typically picked 9 to 10 games right out of 14 to 16 games every week. Uh, I've used, uh, some doctors came back to me and told me my wife had cancer. And so, that's a very stressful thing when a doctor tells you you have cancer. And I told my wife, wait a minute, something's not right here. Give me your data. And so I took all her data and I started doing time analysis, and I started researching what all these tests meant and everything else. And I told her, look, I've gone through your data and I figured out you don't have cancer. What you did have was a lupus episode. And so based on that data, I figured out the patterns. And then she went through a month of testing, and as it turns out, I was right. Uh, and at that point, my wife asked me, did you ever think about being, a medical doctor instead of, an academic doctor? And I told her, yeah, I once considered it for about, I don't know, 10 or 15 minutes. And I decided if I was a medical doctor, my last name would be Kevorkian. I don't like people enough. During an interview, they asked me to figure out what their strategy was. And this 25 boxes in their strategy, and I'm sitting there staring at it. And then they're saying, well, what's your answer? I'm like, wait for it, wait for it. And I said, okay, your strategy's sound, but the boxes are not optimized. And so I was doing Lagrangian multipliers in my head to figure out what the optimal return was. And so they took that information, changed their strategy, and landed $200 million worth of contracts. Ooh, that pissed me off to no end. So, what is it about data? And so, how do I learn how to use data to make superior decisions? And the answer to that is I offer a course in it, Data-Driven Decision Making, which is going to start in the fall. And so if you have an opportunity, that class is going to be fun. I'm not going to focus on the math. I'm going to teach you about how to use data. And so what are my challenges in data? And that's it. Everybody's on the same ground. Uh, and it's becoming a mandatory part of marketing and everything else. And so how you formulate strategy that people can make better informed decisions are the ones who are going to win. So in terms of analytics, though, people are still having a tough time adopting it. And here's uh, data on what actually has happened with people. And you still have to get people to buy into it. So here's an example, for example, search words, how they actually work, the techniques that they use. Uh, I'll let you look at this on your own. Another data example is that one company just looked at mentions. And what they found out with that mentions is the more there were, the more they correlated with the stock price going up. And the reason why they were able to make these predictions is that they could do it in real time. Uh, Netflix uses, they put your preferences on dimensions, and this is, remember the preference vector? All the way back when we talked about positioning, that's what they do. They figure out what your preference vector is. And why do we care about hashtags? Hashtags is it's a label of data. And so therefore it's easy to find and it's easy to track. And so it makes it easy to mine. The key is, again, it's all about your understanding and your insight. And yes, you're saying, Dr. Cho, you're being kind of repetitive about this, but I'm trying to pound into your heads what is important. There is a dark side to data. People use it for criminal purposes. And IBM, uh, when the Germans pulled off the Holocaust, it's hard to figure out the logistics of how to kill. And I apologize if I'm making light of it. But when you think about the enormity of wanting to exterminate 6 million people, you can't do it with pencil and paper. So what did the Nazis use? They used IBM machines. Uh, yeah, and so there's a dark side to this. Uh, and so here's an example of the structure of big data. And that's so we have structured data, which is traditional, semi-structured and unstructured. And this is what they use it for. And so you can see in terms of data velocity, or am I just getting like big chunks of data every day, or am I looking at things continually in real time? Whoops, wrong way. And so we live in an age of data. It's easy to get, but the analytics can help us uncover more opportunities. But the thing to always keep in mind is big data is a tool. It doesn't take the place of you and your creativity.